Welcome back, everybody. Lesson 6, Episode 6 of Technically Bitcoin. Super excited to be back with Tyler after a while. We're looking into runes today. My name is Jan. I am the CSO at Xverse, and obviously beyond working at that company, building the best wallet in the space, I'm just passionate about degening and educating myself about Bitcoin. So that's why I'm here. And Tyler, the sorcerer at Taproot Wizards.
G meow, everyone. Excited to be here again with you all. Casey and Aaron were kind enough to have me over for the Hell Money pod. I really enjoyed that. So I spent the last week knee deep in some Casey and Raph code, trying to figure out how runes are really working, what's going on there. It's been really fun. Some days I wake up and what I learned yesterday isn't true again today. But I think the basic outline is there, and we're going to have a lot of fun running through it today. So basic outline for this episode, we're going to talk about what are runes. We're going to talk about rune stones, something you've probably heard a lot about on Twitter, but there's a different rune stone in the runes protocol. Then we'll talk about etching, minting, and transferring your runes, and then we'll wrap it all up at the end.
Let's go. I'm excited. So let's dive into it. Let's go straight in. So what are runes? Okay, so like the basic kind of idea, what is the promise of runes, and why do we even kind of want to create a new fungible token standard or protocol, Tyler?
All right, so great question, Jan. What are runes? We've got our handy dandy definition up here, and it's a mouthful today, so we're going to break it down for you all. What runes are? They are an op-return-based meta protocol that creates a new UTXO-based fungible token standard on Bitcoin. That's a lot of words. What are runes doing? They're bringing shitcoins to Bitcoin. The casino is coming home. But how it actually works is really interesting. And so the first thing I want to talk about is this concept of an op-return-based protocol. So this is probably something new to a lot of you. It's been around in Bitcoin for a while, this concept of putting an op return in a transaction to include some random data. But let's talk about what it really means. And to do that, I've included a mempool diagram that actually has this is from Signet, but it has a rune, operation going on in it. And the first thing you might notice, and something you probably haven't seen before, is this little orphaned, output. It's not connected to anything. And the question is, why is this here? How did this happen? This thing is no longer part of the Bitcoin network. Like, what's going on? Well, what's actually going on is this output is something called an op return. And what it is it's, as you can see, it's a 0 sat output. So there are no sats. So it is worthless by BTC standards. And then the second thing you'll see is that under that, there is this opcode called op return. So any of you all who have been questing with us over at the Wizards might have learned about opcat recently. Op return is just another script opcode. And what it does is it says, fail the script, do not let anyone spend this Bitcoin. And so what we've created here is a 0 sat output that literally it cannot be spent, because if you try to, the first thing the script interpreter encounters is this thing that says, fail this and do not let anyone spend it. And so what people realized is that you can actually put arbitrary data after an op return. And that is what you see down here where it says rune test. So you can put up to 80 bytes of data after an op return, and it's valid to send around the Bitcoin network. And so people have been doing this for a long time. There's been, like when the Ukraine-Russia war broke out and people were donating Bitcoin, people were like doing stuff with op returns to send messages on the Bitcoin network, and you could include up to 80 bytes of messages. Nice. So what Runes does is Runes says we're going to use this feature of the Bitcoin network to include data on how runes should move around the network. So In this example, maybe there's rune A on this input UTXO, there's rune B on this input UTXO, and what maybe this operturn might tell us, okay, actually I want rune A to go to this first output and rune B to go to the second output. That's just an easy example of the data that might be included in this operturn. So I'll pause there
Yeah.
because I think that's a new concept that's worth taking in for a second.
The most important thing about the operturn, even if you have no idea what it means, even if you're not technical, etc., it's really kind of the place where that we use to let the the protocol know what's happening with the runes, right? Like that's basically the place where we do this, but it doesn't really have any other use, right?
Exactly. And I'm glad you asked that question, Jan, because there is one more point here. And that is that operturns they do not have to be tracked by in the UTXO set
Yeah.
because they're unspindable. And so why this is unique or different is if you compare it to BRC20, which was our first fungible standard on Bitcoin, we ended up with this thing called UTXO bloat, where there's a lot of UTXOs sitting around that now the network has to track. Now, if you're running a node, you're using up more gigabytes of memory to track all of these outputs that no one really wants anymore. They're 546 outputs. What's special about operturn outputs is they get processed in the transaction, so they're noticed by the network. But after that, the network doesn't have to track them. And so we don't end up, adding and adding and adding and adding UTXOs to the UTXO set. And so it's a much more efficient way to convey data about what we want to happen in this fungible token standard.
Yeah, I mean, that's great in terms of obviously having the network to be kind of saved, quote unquote, saved from these dust UTXOs. But I think what's even more relatable to the people that are listening to this is that it's even on the user level, right? Even on the user level, when you have your wallet, and let's say you're a heavy BRC20 user, what ends up happening is that if you're transferring these things around, you're receiving a lot of them in your wallet. You have so many of these dust UTXOs that basically you cannot really use at this point. Yes, you could consolidate them, etc. You could get rid of them. You could send them to the interwebs, whatever, and let people see like order transfers and order mints kind of information in the transactions. But ultimately, there is this problem that you have so many of these dust UTXOs, and you really don't know what to do with them, unless somebody helps you to get rid of them. And so with runes, this stuff doesn't happen even on the user level, right? So it's kind of cleaner and it's easier to understand, I would say.
Exactly. And I think that's a really good transition to our next point. Runes are a UTXO-based fungible token. So we just talked about how data for the protocol is included in these operturns. Well, runes are essentially, I want to say, quote unquote, stored on a UTXO. Stored is, in the same way that an inscription is stored on a UTXO. Or is stored on a set, excuse me. So, let's say we have this UTXO set here. We have a 0.2 BTC. I have a 0.4 BTC. And I have a, 1 BTC output. Well, I may have on this 0.4 Bitcoin, I may have rune A that has a 10K balance. I may have rune B that has 2,000 balance. I may have rune C where I only have 3 of them, and that's totally valid. And then maybe this UTXO has also some of rune A. It's got 2K. It also has some of rune D, and it's got 4 of those. And then we have just a regular old UTXO over here that has no runes on it, no runes associated with it.
Yeah.
That's what we mean when we say runes are UTXO based. And so, as you'll see when we talk about actually transacting with runes and sending them back and forth, whenever you do a Bitcoin transaction, you essentially destroy the inputs and create new UTXOs in the outputs. And we'll kind of see how the runes flow from one UTXO to another. So, really quickly, the first thing we want to talk about is this concept of rune stones. And rune stones may be something you got airdropped into your wallet that could be worth millions of dollars one day. They are also the way we define the data structure that should show up in the op return. So it essentially says a runestone defines how do I, as the runes protocol, read the data you included in this op return. And so runestones allow us to define three functions, essentially. The first one is etching. So that's just creating a new rune. The second one is minting. I think everyone knows and loves that one if you were around for BRC20. And then the third one is transfer. So how do we move runes back and forth with each other, or burn them if you want to? And the last note here is that there's this fun Easter egg in runes that if you make an invalid runestone, it's called a cenotaph. So a cenotaph, in the actual definition of it, is like a gravestone that's built for someone when you don't know where they are. And so if you make an invalid rune transfer, we don't know where the runes should go, you end up with this thing called a cenotaph. And we'll talk a little bit about what happens if you end up with a cenotaph in your transaction later.
Okay, cool, Tyler. So now let's look at basically some of the functions or some of the things that we can do with our runes, right? Ultimately, we want to talk about, the etching, the transferring, the mining, or whatever we want to call it. So let's look into that, and then we can transition into some really practical examples.
The first thing in a rune, and obviously the most fun thing, is this name. So the rune name has to be 13 characters or more to start out with, and spaces do not count. So here, I think technically Bitcoin is definitely over 13, so this is a valid rune name. And the thing to remember about rune names is it starts out with 13 or more characters, but then roughly every 4 months, basically over the 4 years between now until the next halving, the name requirement decreases by 1 character. So in April, we will get these 13 character names. 4 months from April, we'll be able to do 12 character names, and so on. So think about the name you want. If you want the name Bob today, unfortunately, you can't get it. So think of those names that you want that are 13 or more characters. The second thing is a symbol. So this is optional. There's actually a default rune symbol that will show up as the symbol if you don't choose one. But this is just a single character. It can be Unicode. It can be the letter A, whatever fun thing you want to kind of symbolize each element of your rune. The next one is divisibility. So here for our technically Bitcoin rune, we've put a divisibility of 2. And what this means is it's essentially the power of 10 that this rune is able to be divided by. So in our case, I could send Jan 1.01 runes. That's totally fine. If I try to send him 1.001 runes, that's not okay, right? Because that's gone past that power of 10 we were able to send.
And what would actually happen, Tyler, in this case? So if you actually wanted to do it, it would just fail. Or what would happen with the rune if you're trying to send, this kind of to the power of 3 instead of power of 2? What would actually happen in that scenario, unless the wallet obviously saves you and doesn't even allow you to do that? But if you're using the Ord wallet, or if you're doing something very manual, what would happen to the rune?
Yeah, so if you decided to go a little crazy and skip all wallets that are queued up well for this, it's possible you end up making what's called a cenotaph. So we mentioned that earlier, and a cenotaph is essentially an invalid runestone. So any runestone that doesn't conform to the protocol specification. And if that happens, what happens is every single rune in your transaction gets burned forever. So even if you were trying to etch a rune while sending another million runes you had, and you create a cenotaph, those million runes you had burned, this etching burned. Like
Crazy.
everything burned. So
Wow.
be very careful when you're playing around with the
Yeah,
runes
I
protocol.
think this is very important thing to really bring home because you know maybe it's gonna change. Maybe the implementation is not gonna be like this, but for now, like actually, what are some of the and maybe let's go down the list, but basically this applies to every single thing that you can do with the rune, right? So you specify the rune like this, and if you then manually make a mistake, with that specific rune, with that specification, like any kind of mistake that you make in that basically causes this burn, right? So it's actually something that you need to pay a lot of attention to.
Yep. And fortunately, the mint function is very simple, as we'll see after this. So it's
Yeah.
highly unlikely you mess that one up. Where you really are going to get into trouble is when you do transfers.
Yeah.
So if you're playing around with transfers, and we'll talk about those later, it's just important to use a wallet that knows what it's doing, and it's important for you to know what you're doing.
100%. Cool. Okay, this is great. I just wanted to mention it because people have been talking about it on socials, and I don't know. I think Casey is just playing around with the degens. He wants to introduce some element of real gamification here. So we'll see. We'll see
Yeah.
what the real motivation here is. But I think it's important to talk about these things. Um, awesome. So divisibility pre-mine. Okay, what does that mean?
Yep. So premine is the ability to assign an amount of runes. So we're creating a new rune. These are how many runes do you want to assign to yourself? The address that's making this, the first output of this transaction, like how many do you want to go to that? And so in this case, we've decided to premine 1 million. I think this is pretty straightforward. Now, the next thing is the mint. It's called terms. So you can specify terms, and they are essentially terms of a mint. And these are optional. You do not have to do an open mint, but you can if you want to. So I could have just chosen to pre-mine 1 million of these, and that's it. Like there's a million technically Bitcoin runes. But if you want to take the fun and the thing that made BRC20 so special, the open mint, and bring it to your rune, the terms is where you specify this. So the first thing in the terms is this thing called the cap. And the cap is the number of mints that can happen. So this is the max number of mints that are allowed to happen for this rune. So what I've specified here is that there are 20 mints that are allowed to happen. So if you're the 21st person who tries to mint, too bad, your mint's invalid. Like, that's fine. Uh, that is not a cenotaph. You did not burn all your runes. You just tried to mint, and it was, a worthless transaction. The second thing that goes into this is also what's called the amount. So this is the amount of runes that's created per mint. So here, essentially what I've specified is that there is like our technically Bitcoin rune, it's going to have at least 1 million runes because I pre-mined it to myself. And then it can have up to 20 million more runes on top of that, right? There can be 20 mints, each are going to give you 1 million runes. And so that's our kind of max supply here. Now, after that, you can actually specify a few more things, and those are the start and the end of the mint. So if you don't specify anything, it's just open. Anyone can mint it, from here to eternity, as long as there's available mints left. But if you want to time box it, you can, and you do that with block heights. So you have option number 1 here, which is specifying a start height and end height, and these are just raw block heights. So what this says is it says on block 840,000, this mint is open. So any mint that is seen on or after block 840,000 is valid. And then the end height is the block height that the mint actually ends. So on block 840,200, mints are no longer valid. So you cannot put one in this end height. As soon as, like, when that block is mined, having a mint inside that block is not valid. So you have to get it in the block before that, which might be important if people are running, really quick degen mints.
Tyler, question here, actually, very practical. So in this scenario, we have the cap, you have the start and end block height. So how do you create basically an unlimited cap rune that ends at a specific block height? Do you need to specify it in the cap, or do you just keep it basically zero, not zero, but you keep it like, there is, I don't know, what do you put in there, and then you just focus on the end height?
Yeah, so it's actually pretty interesting. I'm pretty sure you can create a rune and specify none of these things.
Okay.
Like, you don't have to specify a single thing in this specification we're going through. And what it will do is it'll say, what is the next, 13 character string that hasn't been used? I'm going to assign that to you. The symbol will be default. The divisibility will be 0. You will pre-mine 0. There won't be a mint. And you've essentially, what you've done is you've claimed or burned that rune ticker. And so if you wanted to go through, and so your question, Jan, it's like, how do I have an unlimited mint? Well, I can just specify a start height, or I can specify no start height, and it'll start when it's revealed. And then the only thing I would specify would be an amount. And essentially, okay, great. Anyone can mint to that amount from here to eternity. And as long as the Bitcoin blockchain's running, you can mint some more.
Yeah, so basically just keep it empty, right? If you don't want to specify a specific thing, you just keep it empty.
Exactly. And there are defaults, and I kind of talked about them, but I encourage you to just kind of, if you want to play around with that, go read through the runes code, play around with it, make some test inscriptions on testnet or signet, or even just in your local environment, and see what happens. Because there's a lot of defaults and a lot of behavior that goes on here that you just kind of want to play around with to really understand what is going to happen.
100%. Awesome. Okay, cool. So what else do we have left here?
Yeah, the last is just, this is the other option. So instead of an absolute start height and end height, you can specify a start offset and an end offset. And this is essentially like, if you put 0 in start height, obviously it's, you can't start at block 0. Block 0 was a long time ago. Runes didn't exist. So what it's going to do is it's going to say, okay, the offset is 0. That means as soon as this etching is revealed, and we'll talk about what that means in a second, as soon as this etching is revealed, the mint is open, and then run it for 200 blocks. So, okay, great. For the next 200 blocks, you're allowed to mint. From block 0 to 199, you're allowed to mint. In block 200, if you have a mint included, it's not valid.
Okay, cool. So anything else do you wanna mention here when it comes to etching? I know that you have a bunch of notes there. Is there anything else that you kind of want to wrap it up with, or should we go into the minting and transfers?
Yeah, let's talk a bit about these notes, and you can read through them as we go through it. And some of this might be new to you all. We didn't talk about it in the ordinals episode because it's frankly not really important as a user. But etching is going to rely on this commit reveal scheme, and ordinals use this too. So if you want to go back and do some research and look at ordinal creation transactions, you might see how this works. But essentially, rune etching happens over the course of 2 transactions. So there is the first transaction, TX1, and this is where you commit to the rune. And what you actually do is you put a hash on chain. And so you're going to take essentially your commitment to this etching. You're going to take all of this stuff we've specified over here. You're going to format it in the way Runes expects to see it. And then you're going to hash that, which essentially means you like throw it through the number blender and it spits out something that people can't figure out on the other side. And this is what you're going to put on chain. So what that is it's essentially a commitment to say, hey, there should be only one thing that when you throw it in this blender produces this string of letters and numbers. And as long as you like give me that thing later, then I know to believe you that, you know, the thing that you said you were going to do is the thing that you gave me. And so that's what the reveal transaction is. So once you do this commit, you actually have to wait 6 blocks. And then you can do transaction 2. So transaction 2 is revealing your etching. And when you commit to it, if we think about this, right, what actually goes on Bitcoin is this hash. So the reason we do this for runes is because when you do that, no one knows what your rune name is. So let's say, Jan, you know, you and I both really want to claim Flying Spaghetti Monster rune. But like, we don't know that each other wants it, but we think that other people might. The nice thing about this is when I put that commitment on chain, you, Jan, have no information about what it is that I've committed to. And so this prevents name sniping from the mempool, which is what happened if you were around for BRC20s. Reindel wrote this thing called the SOFON, which would essentially find any new BRC20 deploy, which was the same, like, you know, the equivalent of etching for BRC20 in the mempool, and it would set the amount to 1. And so it would essentially kill your ability to, you know, make these fungible tokens. And so why Casey and Raf have designed this way is so that you can no longer have this name sniping, this SOFON that sits in the mempool and steals your rune from you, because you have to commit to it, wait 6 blocks, and then reveal it. And the last thing to note here is that the rune that actually, you know, becomes the canonical one, the real one, is based on the reveal order. So it doesn't matter if I committed to the Flying Spaghetti Monster rune first. If, Jan, you reveal the Flying Spaghetti Monster rune before me in a valid way after you'd committed to it 6 blocks earlier. So if we both commit...
Yeah, Tyler, sorry to jump in. Could you actually snipe the reveal transaction, though, out of the mempool?
No.
Okay. So let's come up with a scenario here. So, okay, there is going to be a crazy popular ticker. So let's assume it's going to be whatever, technically Bitcoin ticker blows up and everybody wants to register it, right? Everyone. So there is going to be 50 people that submitted the commit transaction. And let's suppose they were all confirmed in one block. And then everybody is waiting for the 6 blocks. And then when the 6 blocks pass, then basically there's a bunch of people that are submitting the reveal transaction. And so my question to you is, like, can I see if I am like really good at monitoring mempool or I have some tool, can I see that these reveal transactions are happening for the technically Bitcoin? And can I maybe make sure that, okay, we all, like, we don't maybe know, but we all submitted it. So we're going to be like trying to fight, you know, which one gets confirmed first. So like, we're going to be RBFing transactions and stuff like that. So is that possible scenario that can happen?
Yes. And in fact, that's exactly what people think is going to happen at the halvening. So what is going to happen is...
So it can still... So, you know, to my point is that the sniping can still happen. So it's not a fully protected that like, hey, I committed first my
Yeah.
transaction was the first committed one, like I can still basically say, okay, I'm gonna snipe the reveal just to make sure that like I get it.
Yes, but it does require this extra step. So I think with the BRC20 sniping, the way it worked is if I saw a new deploy in the mempool, I would just submit a transaction in that exact same block that paid a higher fee and then said set the amount to 1.
Yeah.
Here, it doesn't matter. I mean, yeah, great. You see technically Bitcoin's rune in the mempool. Cool. Unless you committed to that exact same thing 6 blocks ago, which means you spent Bitcoin, you paid fees to put this on chain, then yeah, you too bad. Like you can't do anything about that.
Yeah. So
Now
it only applies, and sorry, I want to drill down on this, but it only applies basically in case of a scenario if like a very popular ticker that everybody wants, that everybody committed to, and plus they want to do the reveal. So in that scenario, the sniping still exists because there's going to be multiple people, maybe hundreds of people that have the commit, and they just need to be the first one to reveal. That's the only scenario where you could see some sort of sniping, right?
Yeah. And I think I don't really like the word sniping there because sniping to me implies like you see something and then you do something. This to me is just like, this is like a fee war, you know? Yeah. And that kind of brings us to the halving block, which you can go right now. Like as you're listening to this, you can go commit to a rune. And you can hope Casey and Raph don't change the specification between when you do it and when your commit. But if they don't, you can, your 6 blocks have already passed. And so when the halving block hits, you can reveal your transaction and you can reveal your rune then. And so what we're going to see is a lot of people are going to have names that they really want, and they're going to commit to them, a day before the halving. Hopefully the runes code is fixed by then. Maybe Casey will shake it up and really keep things spicy. But, they'll commit to it the day before. And then there's just going to be this monstrous fee war to try and have your reveal transaction be the first one that's included in that block.
Yeah.
And
no, this is clear.
We'll see some fireworks.
Awesome. No, you're right. It's not really sniping. It's really, as you said, it's like an open market, right? It's an open market. Like you really want that ticker. You're probably not the only one who wants it. And so you have to fight for it. But I like the fact that, yes, you're right. It protects against the sniping of that, like, oh shit, I didn't commit, but I see this cool thing in the mempool. I want to get it anyway. So you cannot do that. Like, if you didn't think about it kind of strategically and cohesively, you cannot just like get something out of the mempool that somebody else actually kind of works towards and has a plan and, hopefully is smart about it so that people cannot kind of, or not many people think about the same thing. So cool. Okay. This is very clear. I think this is important kind of distinction and explanation here for people to kind of wrap their head around.
Then let's move on and talk about the mint really fast. I think that will take about 1 minute.
So we have the technically Bitcoin rune mint here. So what is actually happening when it comes to minting of runes?
Yeah. The nice thing about that etching specification is you essentially set how much a mint is, like the amount that you are going to mint in the etching specification in those terms. So for technically Bitcoin, we went and we set the amount to be 1 million. So if you call a mint to technically Bitcoin and that cap hasn't been reached, we haven't had 20 other mints, you will mint 1 million. You do not get a choice on how many you mint. You cannot mint 3. You cannot mint 900,000. You either get 1 million or you get 0. And this is like very nice. It's very elegant. Literally all you need to do is say, here's the rune I want to mint. And if there is a mint left, you will get it. Really, the only other thing, and the only other thing here is that there can only be 1 mint done per transaction. So Um, unlike, we said the rune stone may contain lots of different information in it.
Yeah.
Theoretically, Casey could have made it such that you could, we can put up to 80 bytes in it. Let's say a mint is 4 bytes. You could have done 20 mints in one op return, right? But uh, we don't want that, right? The whole point of this is you have to spend the fees in order to mint. And so just like with BRC20s, it's 1 mint per transaction. You can't mint the technically Bitcoin and the flying spaghetti monster rune in the same transaction. And essentially what that does is it just keeps that open, fair mint mechanic that we all know and love.
Let's talk about the transfers.
All right. So transfers happen through these structures called edicts. And edicts are the way we specify the transfer, the amount of runes we want to transfer and where we want to transfer them to. Again, this is pretty straightforward. You say, this is the rune I want to specify to go somewhere. So here we're saying technically Bitcoin. You say how many of the rune you want to transfer. So in this case, it was 10,000. And then you say the output number that you want it to go to. And we'll do an example and talk about what an output number looks like in a transaction. But basically, each output of a transaction is numbered. It starts at 0 and goes up to however many outputs you have. And so that lets us know where should we send these runes. And if you haven't watched the UTXO episode of Technically Bitcoin, I really encourage you to go back and watch that because it'll give you a good sense of what we're talking about here with inputs and outputs to transactions if the next section is confusing. So the last two things to note about edicts is by default, if you do nothing, all the runes that are included in inputs of a transaction are just going to go to the first non-op return output. So obviously we don't want the runes to be associated with that thing that the Bitcoin network doesn't track and we can't spend. And so if you don't do anything, the runes are going to go to the first non-op return output. The second thing to note, and this is important if you're looking to play with runes early on, is that if an edict or any part of a rune stone really is improperly specified, we talked about this earlier, it creates that thing called a cenotaph. If there is a cenotaph in a transaction that has runes on an input, every single rune in that transaction is burned. Like you lose it, it goes away forever. So cenotaphs are something you really want to avoid. I'm throwing this in here now because a lot of people are going to play with this. Maybe you think you're smart. You're not going to use the Ord wallet. You're not going to use the Xverse wallet. You're just going to inscribe the text directly because you think you understand the rune protocol. I support you doing that, but be aware that if you make a typo, you will burn every single rune that is included in your transaction. So I cannot stress this enough that be careful when you're playing with runes because you are actually playing with fire.
Awesome. So I think that's it, right? Like we have covered basically all the functions. Isn't that true?
Yep, that's it for the functions. So
amazing.
I think with that,
let's go into the example because I really want to cover this. I really want to look at like a specific example when it comes to looking at UTXOs, looking at your wallet, looking at your address, and basically moving these things around because I think that's something that is also going to reveal what we have talked about, up until now in terms of the differences between BRC20s and runes and why is it more efficient, why is it better, like if you want to look at it from that angle. So let's do the example.
All right, so welcome to the runes example where we really understand how this stuff works. So I'm going to set up this transaction and then we're going to walk through how it actually works. So for this transaction, we're going to have two inputs and I'm going to be the owner of both of them. So here's Tyler, I own this one and I also own this one. And the goal is going to be to send some runes to Jan. So I'm going to send him some technically Bitcoin runes and some Quantum Cats rule runes. And we're going to see how that works. So before we look into how it works, let's see what is the initial state of our system here. I'm going to have two inputs, like we said. And this first one is going to be 0.2 BTC. And it's going to have some runes on it. So it's going to have a technically Bitcoin rune balance on it. And that's going to be 25,000. So I'm going to have 25,000 technically Bitcoin runes on this first input. Let's say Node Monkeys made some runes, and I have 30 Node Monkey runes on here as well, right? Because we can have multiple runes associated with a single UTXO.
Yeah.
And then on this second one, let's say it's 0.5 BTC. And over here, I'll have the Quantum Cats rune. Let's say I have 10,000 of these. And then let's say, maybe there are some other runes on here as well. So there's the PP rune. I think that sounds like something that the puppets would have. So let's say there's 500 of those, although I guess they like the BJ rune. So we'll add one of those too. Let's say I have 3 BJ runes. So this is the state of my, wallet, for lack of a better term. I have a total of 0.7 BTC. So that's just the total Bitcoin I have here. And then I have this balance of runes across these 2 UTXOs. So now I want to send Jan. I want to send him 10,000 of the technically Bitcoin rune, and I want to send him 3,333 of our Quantum Cats rune. So how am I going to do that? Well, we're going to include these 2 inputs, and we're going to create this transaction. And the first thing we're going to do is we're going to create our op return. And so that's what we see up here as this first output, over here. This is our op return. Push num 13 is what actually specifies this is the rune protocol. So Casey said, we're going to go with lucky number 13. So if we see an op return followed by push num 13, we as the rune indexer say, hey, let's pay attention to this. It's doing something we care about. Yeah. And then we have these 2 edicts. And these edicts say we want to send 10,000 of these to output, and excuse me, I'm going to change these to output number 1. And we want to send 3,333 of these to output number 1, because this is output 0 and this is output 1. And there are some special rules where you can actually create big fanning transactions. If you wanted to say distribute all of your runes mints to a bunch of UTXOs. And I don't want to get into that now. So we're going to just stick with 0 and 1 outputs.
Yeah.
And so output 1, I want that to go to Jan's address. Because as we said in this edict, output 1 should have the runes we want for Jan. And so as this edict gets processed, what it's going to do is it's going to say, okay, great. On output 1, let's go and let's give this 10,000 of the technically Bitcoin runes from the balance that was available in the inputs. So there was 25,000 available. And then what it does is any unassigned rune is just given to the first output, the first non-op return output. So this one, I want to make sure it just goes back to an address I own. And the runes protocol is going to say, okay, great. It looks like there's 15,000 of these left over. So Tyler, you get your 15,000 remaining here. We're going to do the same thing with the Quantum Cats. So Jan, you get your 3,333. And then over here on this UTXO that goes back to me, I get the remainder, which is 7,000 or 6,777. Perfect. And then all these other ones.
I think it's wrong, Tyler. The math is wrong. It has to be different. It has to be 677.
Oh, yeah.
It's all good, man. It's all good. I'm here to catch the math.
There you go. Yeah, it's been a long day. They don't teach you math in PhDs. They just teach you how to be poor. So,
okay, nice.
All right. So then the PP, I get to keep my 500. The BJ, I get to keep my 3. And
Yep.
then let's look at how much Bitcoin is on each of these. So I don't want to send Jan a bunch of my Bitcoin. I want to send him
Why?
as little
I
Bitcoin as
want some Bitcoin,
possible.
Tyler.
We already established that I'm poor, Jan. I can't be given handouts to
True.
the wealthy ex-verse CSO. Uh, so my friend, you get
Yeah.
546 Sats, and I'm going to keep basically what still looks like zero point 0.7 BTC.
Yeah.
And then
Obviously.
obviously, let's say we spend 10,000 to fees. But
Yeah.
by and large, the thing to note here is that the Bitcoin balances should not really need to change much in order to
Yeah.
do runes. We don't have to
Yeah.
preserve the size of the UTXO or anything like that. And so now, Jan, we've successfully transferred you 10,000 technically Bitcoin runes and 3,000 ish quantum cats runes, and you have this one output. I have a new UTXO, and now I only have one UTXO, and it has all of my runes on top of it. One quick note, I think, Jan, you hinted at this, but I kind of want to hammer it home. The
Yeah.
difference between this and BRC20, right, is that in BRC20, the way we would have had to do this transfer is I would have had to make a brand new UTXO via another transaction that said Tyler, and it said, transfer 10K of the technically Bitcoin. And then, in fact, I would have had to make another one on top of that because that only allows me to do one. I would have had to make this other one, and it would have said, transfer the quantum cats balance. And so, as you see this, you can see how with BRC20, this is the BRC20 example. We end up making all of these new UTXOs that we don't really want or need, and then I have to send those off to you. But then I'm left with this, old UTXO. Maybe I've sent it all off, and so this op return really helps us keep the protocol more efficient.
What if I now want to take, let's say, okay, I have 3,000. No, yeah, this is Jan. I have 3,333 quantum cat runes. So I want to transfer 333 back to you, Tyler, because I don't know, we made a deal or something like that. So what happens with all the UTXOs? What happens in my wallet and your wallet?
Awesome. So yeah, let's get into that example. So if we kind of set ourselves up here again, we're going to have some inputs to this transaction. And, the goal here, as we stated, is for you, Jan, to send me 333 of your quantum cats. So here in your, you're going to have your UTXO, that's 546 sats, and you have a quantum cat balance on it. And then you also have a technically Bitcoin balance on it of 10,000. So uh, it's going to be really hard for you to send that without anything else. So let's make sure we put this as your UTXO. Let's say down here, you have another UTXO in your wallet that's zero point 0.2 BTC, and it doesn't have any runes on it. This is what you're just going to use to pay fees and make sure that things stay above the dust limit. So now what you're going to want to do is we're going to need to make some outputs. And your goal here is to send me 333. So output number one is going to look just like it was before. It's going to be the edict that's in the op return. And what you're going to do is you're going to say you want to send rune quantum cat. The amount you want to send is going to be 333. And we're going to make my output the second one, and there's only going to be two outputs, so it's going to be output number one, because remember, the first output is output number 0 and the second one is 1. All right, so then the second output you're going to want to make, I shouldn't say second. The first output that's beyond the op return one is going to be yours. And we want to do that because you're the one sending the runes, and we want anything left over to go back to you. So we're going to say, Jan, you're the first output. And then we're going to say, Tyler here is going to get the second output. How much is going to be on each output? Well, Jan, you, again, don't feel generous today. So you want to keep most of your 0.2 BTC. You're going to have to shave a little off for fees. Yeah. And then we're going to make another output for me that's going to be 546 sats. And our runes protocol is going to look at this edict. It says, okay, great. I'm going to send 333 of these quantum cats runes to the second output. And then for this first output, you get what's left. So for the quantum cats, you now have 3,000 of those. And obviously you get to keep your technically Bitcoin ones. So there's still 10K of those there.
Nice.
And so if we do this transaction, these are the inputs, these are the outputs. And if we want to say, like, what's Tyler's final wallet state? Well, I have this other UTXO from the previous time, and it has a bunch of stuff on it. It has 15,000 technically Bitcoin. It's got 6,667 of the quantum cats. It's got the 500 of the PP. It's got 3 BJs, and it's still worth 0.7 BTC. So now this is now the status of my wallet. I've have these two things, these two UTXOs in it, and then I now basically have runes split across two of them. So I have a balance of 7,000 quantum cat runes, but this top UTXO that's 546 sats holds 333. The remainder is held on this larger UTXO that was created from our previous transaction.
Nice. Perfect. Yeah. And we could actually, talk about further, like, what happens next, right? Like, if you decide to send, let's say, 1,000 quantum cats, etc. I think, it's not maybe necessary right now, because I think we have kind of like showed the point here. What I would like to talk about instead is maybe look at some other extreme example. Maybe the last one that we're going to cover today is really what happens if, let's say, we have done these steps multiple times and you have been degenning for a while, and your wallet has maybe 10 different tiny UTXOs with different balances of, either the same rune or different runes. So let's cover that example to kind of, again, bring it home what really is happening with those UTXOs when, your wallet now has, like, maybe not 10, maybe let's start with 5 or 7, but basically kind of like, showing that and what happens if you want to be transferring them around.
Okay, so we're gonna go through now and let's look at let's do 6 inputs, or let's. I'm not even gonna call these inputs. I'm gonna call this a wallet because we're not gonna send all of them in a transaction. So let's say you've been degenning for a while, and you now ended up with 6 UTXOs that all have the same rune on it. Maybe one's different. So we're just going to use single characters here. So let's say here we have a rune. We have 10 of them. Here we have an A rune on this UTXO. We have 6 of them. Here we'll have 7. Here we'll have 12. Maybe we happen to have one with B. We have 100. And then this last one is also A, and it has 20. All right. So now the question I think, Jan, you wanted to talk through is what happens if, let's say, this is my wallet state, and I want to transfer you a rune balance of, let's say, 35. How do we make that happen?
Yeah.
Great. So I'm going to circle the ones we're going to make as inputs to our transaction. And the way we're going to do it is we're going to choose we're going to send 35A. And what we want to do is we want to choose the ones with the biggest balance first. So this one has a balance of 20. Great.
Yeah.
Like we've gotten up there. This one has a balance of 12. So now we're at 32. And now we need to get 3 more. If all of these are the same size output, literally the fee is the same, everything is the same. You can pick whichever one of these is your favorite rune to use in this next one. We'll use the 6 because it's smaller, and maybe this way we're hoping we can get rid of this UTXO in a future spend. And so what we're going to do is we're going to take these, and then I'm just going to call this a fee UTXO. So this is just going to have Bitcoin in it. And we're going to take all 4 of these, and we're going to make these inputs to a transaction.
Nice. Yeah.
All right. And so if this is, let's say this is Tyler's wallet, and I want to send something to Jan. Okay, well, each one of these is 546 sats, plus we're going to have this fee transaction. We're still only going to want to make the outputs. We're still only going to want 2 outputs. We don't need to make more UTXOs. We don't need to preserve numbers of UTXOs here. So our first output, as usual, is going to be our edict in our op return. And this says we're going to do rune A. We're going to do, what did we say? 35 of it. And the output we're going to send it to is output number 1. And then we're going to make the second output. So this is going to be Tyler. And then we're going to make the first output Tyler, and we're going to make the second one Jan. So remember, this is output number 0. This is output number 1. And we're specifying these go to you, Jan. So again, I'm going to give you 546 sats, and you're going to get a balance of A of 35.
Yeah.
And then I am going to take the remaining, let's say this fee is getting spent all to fees. I'm like, well, I'm not giving you all of these sats. So now I'm going to end up with a new UTXO, and it's going to have 10,092 sats. It's not going to have any runes on it because I sent you all the runes on the inputs. And these ones we didn't send at all. So they didn't leave my wallet. So, and maybe putting an arrow there is unhelpful. Let's say an X, right? Like these did not go anywhere, right? I didn't include them as inputs to the transaction. Only the ones that I circled were inputs to the transaction. So those stay in my wallet. Yep. And what we end up with is I end up with this 10,092 sat UTXO with no runes on it. Great. Like it's a little bigger now. I had to consolidate these UTXOs anyway. I might as well keep the remaining balance. And then you now have the 546 sat UTXO with 35 of the A rune on it.
Okay, but one question. Where did the remaining 3 go? Because
they didn't They didn't go anywhere because I didn't include them in a transaction. So if that's the wallet,
no. What I mean, sorry, I don't mean the X's. I mean the A, right? The A rune, because
that is totally wrong. I should have kept 3 of the A rune.
Yes. So I mean, that's fine. I think we should definitely include this because we want to kind of like make sure that people understand. So basically what's happening here, there is not going to be nothing on it, but there's going to be the 3 of A rune because that's the stuff that is left over, and it's part of what we were, sending around. But obviously the X's, the ones that we didn't even include into this transaction, obviously they stay in your wallet, so they're there. They're not really going anywhere. They're not changing any, UTXOs, whatever. And so the only thing happens here that we're adding this UTXO to your wallet, which has the 3 of A rune, correct?
Correct. Yeah. Man, if I've learned anything from today's episode, it's that my mental math has suffered in the last 33 years of my life, apparently.
No, but it's cool. I mean, ultimately, this actually, again, it really, I like it because now people, see how it actually works, and we kind of even highlighted, some of the stuff that maybe people could like, kind of lose track of, if they're not like 100% familiar with this concept. But I think now it's pretty clear. And so, what I like about this example specifically is that you clearly see how this is different to BRC20 tokens because you're actually seeing, hey, we started with so many UTXOs that have different runes on them, maybe the same runes, but different quantities, different amounts of those runes, because you may have received them from different people, different transactions, and that's why you ended up with a wallet looking like this. However, when we then do the further transferring, we're actually consolidating those UTXOs with those small balances. And this is kind of like how the runes are going to be moving around the network and people's wallets. And so that's the point where we can say clearly that this protocol is much more efficient and it's actually kind of made for these things, made for Bitcoin, fungible tokens, and it's way better. So, that's really the point that we wanted to drive home here. And I think it's pretty clear. I don't know if there's anything else to add, but to me, this is very clear.
Yeah, no, I think we've made it through the entire Runes protocol. I think people will learn a lot more as we actually see it in practice. As people start clicking on the mempool transactions, they're going to be opening up this op return data. They're going to see the number 13 appear a lot.
Yes.
But yeah, it's it's not that complicated of a protocol when you actually get down into it. What we talked about is essentially that runes are moved around and the protocol is described in these op return outputs that are unspendable. We talked about how you can create new runes through etching. We talked about how you can mint runes if you so choose. And then we talked about how they're sent around the network. And I think how they're sent around the network is really the key to understanding how this whole protocol works.
Amazing. I think that's it. Tyler, thanks so much. I mean, it has been a longer episode today because we had to go through a lot of stuff. And, I'm just excited to see what's going to happen with runes and how the protocol, even develops. Maybe we could be adding some more content to this because maybe Raf and Casey will decide to, change it or improve it further or add some additional functions. Who knows, right? It's the point where, like it's still being developed. And so you guys should be paying attention. And obviously this video kind of gives you this episode gives you like a pretty brief description of the logic. And I do believe the logic will remain the same, but it could be, it could be improved. It could be expanded. We'll see how it goes, but just super excited to see what's going to happen with runes. And, yeah, let's get ready for the halving block. I think that's going to be it's going to be a movie,
It's going to be a good one. All right. Thanks, Jan. Hope everyone enjoyed the episode, and we'll see you all next time.